Okay, good afternoon, everyone. Welcome to our distributed generation low voltage workshop for ICE. Today, we're going to be covering two main topics. Obviously, we will go through the agenda, and we've got a slide to introduce the people from Electricity North West who are on the call today. In terms of the agenda, we have a section on our G99 example forms where we'll go through and talk you through an example form that's relevant for generation at low voltages. Then we'll do an update on our ICE work plan for this year. And then the second main event today is an update on our transition to distribution system operation. And then that should take up to about an hour, and then we've got plenty of time at the end for questions and a wrap up and close. So to introduce the team, Amy Matheson, who many of you may know, she's actually gone on maternity leave now, so I will be hosting today's event. And we also have Lottie Wheatcroft, who's joined the team as our new Incentive on Connections Engagement Manager. In addition, we've got Jill Williamson, who will be doing the G99 forms presentation, who is our Strategic Planning Manager. And we have Keith Evans, who is our DSO Transition and Smart Grid Engineering Manager, who will be doing the presentation for our DSO update. On the call, we also have Martin Edmondson, who is our Head of Business Connections, and Brian Hoy, who is Head of Market Regulation. And I believe Simon Taylor should be joining us. I don't think he's joined us just yet, but he's our Customer Relationship and Performance Manager. So, as I say, the purpose of today is to give you some presentations and to share some of our understanding of G99 DSO and our incentive and connections engagement. But this is an opportunity for yourselves to ask questions, to provide feedback. So we do encourage you to get involved. And the way you can do that is you can either add things to the chat function, or if you'd like to speak up, if you raise your hands, we will come to you at a suitable point in each of the presentations. We will also do a little poll at the end of the webinar just to get your feedback on how useful you found it and what kind of topics you'd like us to cover next time. We would appreciate if you would take the time to answer those questions. It should only take a minute of your time. So without further ado, I shall hand over to Jill to start her presentation on G99 example forms.
Thanks for that, Hannah. I've taken control, I think. I'm going to test it to see if we're moving down slides. So let's have a look. Do we need to click? We click. Understood. So has that changed for everybody? Got some nods, so that's good news. Thank you. So I've got, I think, 20 minutes on the timetable here to take you through some of the G99 forms, and we're going to be concentrating on type A and LV generation. What we are assuming here is that you'd be most interested in the G99 type A forms at LV. G98 forms are a simpler approach with notification, and we've got some information on our website about that process. What we're doing today is in response to some feedback that we received last year, actually. So this is a case of, you said we've done approach. And it was suggested that it would be handy to have some examples of the G99 forms. We fully appreciate that G99 forms are not the simplest and are evolving. And in fact, the latest amendment of G99 was approved quite recently. So I'd encourage you to have a look at the Decode or the ENA website to make sure that you're working to that latest version of G99. So what we're going to talk through is some example of a 9.9 kVA solar PV generator connection application and run through the required information. If we can get your feedback, and as Hannah said, we can use the hand function to take any comments. It's quite a small group, so happy to take queries and comments throughout. So that we can refine this example and what you're needing from that, so that we make it as useful to you as possible. So what we are going to talk about is LV generation, and the typical types are indeed inverter connected PV, inverter connected storage, and then synchronous CHP. So that will be our focus. You might have seen this little summary before, and indeed it's available in a sort of version of this on our website. We use it quite extensively internally at Electricity Northwest because it is a good guide to what form is required for what size of generator and at what stage within the process. What we're going to focus on today is the type A, less than 50 kilowatts under G99 forms. So as you can see here, we're going to be talking about the application form A11, the notification form A31, and then explain to you the need when the evidence forms are needed. And we're going to be focusing on the A23, which is the inverter connected form, but you can see here if you were connecting a synchronous generator less than 50 kilowatts, it's the A21, and greater than 50 kilowatts for synchronous is A22. So as I say, have a look. If you've not seen this little summary before, you might find it useful, and it's available on our website. So when we look at these forms which are submitted by our customers, we are seeing some reoccurring themes which we think it's useful to address. The first one very much relates to the right form. That's the right form at the right stage in terms of that little summary that we've just talked about, but also the latest amendment of the form. As I say, G99 has just recently been updated. I think it's Amendment 8 that we're talking about now. So I would encourage you to make sure that you're dealing with the latest forms. The other common issue that we face is use of the manufacturer's reference number on the application form. This is something that I've got a few slides on here just to explain it, because it's not the easiest. The reference number is related to type testing, and all manufacturers are using the ENA type test register to record compliance with type test needs and requirements. The ENA have kindly and helpfully color-coded their type test register. You need to be looking for greens. That means that they're compliant. If it's looking like an amber colour or an orangey colour, that means that the ENA have not actually checked that type test application yet, or type test submission. And if it's a grey colour, it means that they're awaiting information. If you see on the ENA type test register that the piece of equipment that you're installing is green, that's really good news, because that means the compliance evidence has already been filled in. And what we're going to talk about later, which is the compliance forms, you don't need to do that yourself. You can just rely on the type test register, and indeed that's what we will be looking at. The type test register has got lots of information in there. The manufacturer's data is uploaded, the forms are uploaded. We as DNOs have got access to review all of that data, and we're able to check all of the details that demonstrate that the type test has been satisfactorily completed, and indeed that generator is compliant. So let's start by talking about the forms in detail now. So using the helpful summary, the colour coded that we showed earlier, you'd have identified that the form we need for applying for the connection of a generator greater than up to and including 50 kilowatts is indeed the A11. This is a fairly short form, but has got really important information in there, which is going to help us to assess the application for this generator. There's some rudimentary information on contact details and the installer details. And on page 2, the site where it's going to be connected. Also includes any information on existing generation and the technical information of the proposed generation. This is where we have the manufacturer's reference number. There's also a signed declaration. That's where we are seeing your commitment to demonstrate that indeed that the generator you're going to be installing does indeed comply with G99. So, manufacturer's reference number, where on earth do we get that from? Well, it comes from the ENA type test register that we've just been talking about. The type test register on the left-hand side has got essentially a search facility. So that's where you will be able to enter in your manufacturer number, the device number if you know it, or perhaps the rating or the type of the equipment. You can then undertake a search, and the register will spit out a list of all of the generators which it's got on its type test register, matching the filters that you've actually put in there. So what you can see is a whole list of data, and as I say, it will be color coded, but this is where we actually get the reference number from. Here you go. So on this slide here, you can see what we've done is matched up the columns of the type test register with where the information gets inserted into your application form. So the manufacturer name is there, the technology name is there, the rating is there, and importantly, the first column on the type test register is your type, your manufacturer's reference number, and that's what we need on the form. So that's a useful little mapping there for you, and I encourage you to have a look at that when you're filling in your next form, application form, if you've not been aware of that before. So now moving on to post acceptance. So if you are like this 9.9 kilowatt generator that we're talking about, and indeed any type A's, you're going to need to fill in a notification form when you've connected that generator. So in this particular case, and in fact, I think it's for all generators, type A generators, other than integrated storage, you're going to be using the form A31. So what this form again is looking for is some of the details about who the installer is and where the installation has been made. But again, it's looking for some technical information and confirmation that commissioning checks have been undertaken. For generators less than 50 kilowatts, we won't be witnessing the commissioning checks. So this is filled in by the installer and submitted to ourselves without the need for any commissioning checks. Page 3 and 4 are actually signed and filled in by the commissioning engineer, and there's a series of yes and no questions to be completed there. As I say, there is a gap for our witness, but we won't be doing that in the case of this 9.9 kilowatts. The standard approach at the moment is that we potentially will witness tests for greater than 200 kilowatts. And there are separate forms to be filled in for those as well. That tends to be associated with export limitation. Excuse me. The notification form will be sent into ourselves, and that's when we check that indeed the generator that you're connecting is G99 compliant. So if you don't have a type test and it's not on the ENA type test register, or it's amber or grey on the type test register, that's when you're going to need more than the two forms that we've talked about for LV generation. I would say that that's not very common, but it's an eventuality we need to talk about. The one thing that is more common is if you are connecting a generator greater than 16 amps, there is a likelihood that we need to check and be assured of the compliance of the generator to power quality standards. So although we've got these two forms here, separate to this, if it's more than 16 amps, we will be looking at power quality, and that's something that our engineers will do and work with you to ensure compliance. So moving on, the form that is needed if the generator is not type test compliant is the A23 form. I'll be really honest with you and say it's not a particularly easy form, and that is therefore really helpful that we're not going to need it that often. And it is a form that I would expect the manufacturer to be helping with rather than the installer taking sole responsibility. Sorry, there's another question popping up there, but it's disappeared. Anna, can you help me out with that question?
Yep, so we've had a question saying, how can form A31 be filled in by commissioning engineer prior to testing?
So the A31 form would be filled in as part of the commissioning process. And that would be typically done as part. If you needed to do site tests because it wasn't a type tested generator, they would be both done at the same time. So the A23 if there was any site tests associated with that, and the 3.1 would be completed at the same time and submitted at the same time. Does that answer the question? Is everybody on mute, Anna, or is everybody, can everybody take themselves off if they need?
They should be able to take themselves off if they need.
Brilliant.
Either a thumbs up or a chat or
shout out, yeah. So conscious of the time, so I will put a wriggle on this one. So A23 is the right form for a inverter connected and asynchronous generator. And what this form does is actually step through all of the tests that are required to demonstrate compliance for a type A G99. So this is a form which is not specific to an individual site, but is specific to an individual type of generator. So on this form, there's no information about where you're connecting it. It's all about the generator that you're connecting. So we're kicking off there with some information about the actual generator on page 1. It starts off with a summary, a helpful summary, which allows people assessing compliance to check that we've got ticks in all the right boxes. So here we've got a list of all the tests that are needed. They could be factory tests or they could be on-site tests to be able to check compliance with G99. It is really for a manufacturer or somebody fairly technically astute and familiar with G99 to be filling this in and signing it off. So then we move into the nitty-gritty of these tests. I'd encourage you to have a look at G99 to understand what all these tests are all about. G99 is several hundred pages long and there's lots of detail in there about the tests. We are starting off with tests which are about the capability of the generator to continue operating over a whole range of frequencies. So what we're seeing here, and this is likely to be a factory test because it's not something that we can actually do, is manage the frequency of our network on your particular site. So this is a factory test, the manufacturer, and the manufacturer is going to subject that generator to operation at frequencies between 47 and 52 hertz and check that it can continue to operate within the durations required by G99, and that's what we're looking for here. That typically comes in the form of a trace of frequency and generator output to demonstrate that it's continuing to operate stably at those frequencies for the required period of time. So I say factory test normally. Moving on, we also have got a series of power quality tests. This is where the generator will be run and the harmonic currents will be measured. So table here for harmonic currents. Similarly, we've got a table of flicker values which will be measured, and there's lots of good information in G99 about how the source impedance at the test site is taken and normalized so that we can compare the flicker values with the values, the limits within G99. So harmonics, flicker, and then also there is some parameters here in terms of the DC injection. There's limits on the amount of DC current that we are permitted to have for particular outputs of the generator. So we're going to be to check compliance. We're also looking for measurements of DC current. So as you can see, these are not the simplest, and it would normally be the manufacturer who looks at those three power quality parameters. When I mentioned that we needed to do power quality checks for anything which is greater than 16 amps, those tend to be on the back of the technology type, actually. So the new power quality requirements, which is G55, first of all, check technology type. Should that be a 6 pulse or a 12 pulse type inverter? And also the rating. And that's the checks that we'll be doing as part of the connection assessment. So you indeed may be asked about what technology. We can probably get that from the manufacturer's reference, because we can have a look at this ENA website. Following on from the 3 pages of power quality, there are, I think there's 3 pages of protection as well. So we're looking at under and over frequency compliance, making sure that the trip is done at the right levels in the right time. Also, we're looking at under and over voltage tests, again, checking that with no spurious trips, and similarly for loss of mains. So that's a rate of change of frequency, again, making sure that we don't get any spurious trips. All of those tests can be undertaken in a factory setting to provide a type testing requirement. And indeed, we can also accept family type tests as well. The last parts of the form are about some wiring requirements and reconnection. We also look for confirmation of the fault in feed. These are not something you're going to need to do every day. These are one-off requirements for the particular type of generator that you are connecting. So please don't be too concerned about this form A23. We are providing an exemplar just so that you've got that should you come to need it. However, I'm not seeing that it'll be a very common occurrence. Say the last forms are more about some of the one-off requirements of these generators. So you can see here, G99 requires that type A's have got a logic interface. What that logic interface does is allows a signal to be sent to the generator, which essentially controls, sends a signal to cease export from that particular generator. And G99 requires that a generator has that logic interface. So the type test, as you imagine, has got a tick box which essentially says that logic interface exists. So in summary, we are looking to put these exemplar forms on our website. There already is some guidance on there in terms of filling in, I think, G98 forms. So this will complement that for the type A G99 forms. Sorry, that was quite a whistle stop. I think I might have just bust my 20 minutes. Hannah, how are we doing?
Yep, just slightly over. Thank you very much, Jill. As I say, this is something we're developing this year as part of our commitment. So, it would be really helpful for people to let us know what works for you, what doesn't, how we can make it easier to understand, and what we can do to kind of help you along the way. Liam, you just raised your hand. Did you have a question or a comment?
Yeah, just a quick one for Julian, if that's all right, just before we jump on something else. Just when we're filling in the G99A1-1 form, say if I had 3 blocks of flats that each had a 9.9 kilowatt PV array on them, would I be able to fill the same form in, but put all 3 of them under the new apparatus, or would be required to fill out 3 separate A1-1 forms?
I presume that those buildings are going to have their individual point of connection with the ENW network, or are you talking about an
Talking
IDNO?
about, say if it's a HV supply that we're doing for ENW, so it's say a brand new substation coming in, 3 different feeds to each block. Would I require then to put all 3 of them on one form, or would I require 3 different forms? I just know some DNOs let us do it, some don't. So I'm just trying to get everyone's response of what I can and can't do.
So is that an ENW substation, or is it
Yeah.
a HB? Right. So in which case I would say those have got 3 individual points of connection to our network, 3 metered points of connection, and
Yeah.
therefore it would be easy if you did 1 per site, please.
Okay, no, that's fine. Thank you very much.
No problem.
Any other questions or comments? Okay, in which case what we will do is when we send out the slides, we will give you an opportunity to look through the slides in a bit more detail, because they have obviously contained an awful lot of information on those. If you do, when you go through the slides, have any comments or any thoughts, please do let us know.
If that's okay, Hannah, I have actually got an ENA EU codes meeting, which is also covering G99, so it's very apt timing.
Okay.
Brilliant.
Thank you, Jill.
Do you need to pick control up before I leave?
I've got control now.
I'm leaving. Thank you, everybody. Take care. Bye.
Okay, so our next presentation is following on from that to give you an update of some of the other commitments that we've made for this year in terms of actions we will do as part of our Incentive and Connections Engagement work plan. So I will go through the commitments and give you an update on each. Hopefully you are all familiar with these commitments that we've made for this year for generation at low voltage. So we have a general one on satisfaction. Obviously that is something that's extremely important to us, and we do target high customer satisfaction, and we do that through a quarterly survey. So if you do receive one of those surveys, do please respond. At the moment, that is currently on target. We are just about to do a new survey at the end of this month. But yes, we are on target with that. Another element is the time it takes us to provide you with a quote for this type of work, and we've put a target in for 22 working days on average to turn those quotes around, which is an improvement on the guaranteed standards. And we are currently delivering those on average at 21 days as of end of July. So both those are on target. As a group, one of the things that our stakeholders have said is what we're doing as an organisation related to green energy and the wider green economy is important to yourself. So we committed to keep you updated, specifically around some of the installations that we are doing as case studies on our own buildings and our own fleet. So some of those have been impacted a little bit in terms of by COVID, but we are making progress with those and would expect to be able to give you to share our learning at our next workshop. So hopefully you'll join us for that. We did provide a bit of an update at our previous workshop as well. The G9899 application process we just covered with Jill, and again we did an initial presentation at our last workshop, which you should be able to view the slides on if you wanted to refer back to those. The next commitment is about our transition to carrying out enhanced distribution system operation functionality, which is all about becoming more of an operator as opposed to a network owner. So there's an awful lot involved in that, and Keith will be providing an update straight after this presentation. And in terms of what we've delivered so far, we've published our DSO strategies, and that's following a consultation we had last year. We've also published a draft transition plan for the next regulatory period, which is ED2, which runs from 23 to 2028. And as I say, Keith will be doing a presentation in just a moment. Our next commitment is regarding quite a significant change that Ofgem are looking at, which is their significant code review. Now, we presented a briefing in August of their minded to position. I think the consultation following that is closed now. I will have to double check. We will provide you with a briefing when we receive Ofgem's final decision on that. That is expected towards the end of this financial year. It may drop into next financial year, but as soon as Ofgem publish that, we will pull together a briefing to share that with you. And Brian's just confirmed, yes, the consultation is now closed. Okay, so keep your eyes peeled for that towards the end of this financial year. Our next relates to community and local energy, which is a subgroup of our distributed generation at low voltage, and we have a community and local energy manager who hosts a number of events and engagement opportunities specifically for that group. And we committed to doing a minimum of 3 opportunities for you to join our events. That is on target. We held our first in June, and I've got us, the next slide actually is promoting our next event, which is the Powering Our Community launch. On a similar vein, we also committed to doing 3 engagement opportunities for this group, which this is our second one. The first one was delivered in July, and we have our 3rd workshop planned in January. So feel free to register on that event, and we do host additional sort of topic-specific webinars throughout the year as well. So again, all of these are available on our website if you wish to register to join those. And to keep our stakeholders informed throughout the year, we also do quarterly newsletters. The next one, which will be coming out at the end of this month, and if you would like to receive those, just let us know either through the ICE mailbox or sign up to our distribution list on the website. So myself and Lottie form the ICE team along with Amy when she comes back. If you do have any feedback or comments, or if you'd like us to cover any particular topics, then please do let us know on the ICE mailbox there. And here's a slide about our Powering Our Communities Fund, which is this Friday at 10 AM. You can still register for the event. The Powering Our Communities Fund is something we've done for the last few years, and it's about supporting community and local energy groups to develop and grow. And what we do is we have a fund that we ask groups to apply for, and this is about helping community and local energy groups get up and running, and to actually get past some of the barriers that those groups sometimes find. The event on Friday will launch this year's fund, and will also feature some previous fund winners who will talk about what they've done and the impact that's made. Okay, so that is our work plan for this year. As I say, we are generally on track and continuing to develop. If you do have any comments, let me know. At which point I will now hand over to Keith to deliver our DSO update.
Good afternoon. My name's Kevin. I'm the Research Transition and Smart Grid Engineering Manager at Electricity Northwest, and I'm going to give you a brief overview of our distribution system operation transition. Now, I've given a few of these before, so I'll just kind of run through the kind of key updates. So the headlines since the last time we updated you. So we've launched our draft DSO ED2 transition plan. So that sets out our plans for the years between 2023 and 2028. And that's quite a detailed document which looks at how we're going to transition to distribution system operation over that period, and gives you kind of a bit more of an in-depth idea of what those plans are. And that's designed as the kind of guide for what we're requesting in terms of funding from Ofgem for the next price control review, and how we're going to meet the baseline expectations that they've put in front of us and exceed them. The other document that we've published since the last update was the DSO strategy, which was updated since the original consultation document that was published in 2020. And again, that gives a bit more of a kind of long scale how we're transitioning to distribution system operation, and kind of is a bit more high level in terms of the how it describes that transition. So what I wanted to do today was actually talk through active network management. Active network management, for anyone who hasn't come across it before, so it's a way of generating the smart grid. So it's a tool in our armory of the smart grid, and allows us to connect more generation, storage, controllable demands. And it's a software package that we use to monitor and control the operation of these devices. Under the scheme, it allows us to utilize flexible connections, flexible services, and flexible assets to actually utilize the network more efficiently, and to get more kind of capacity out of the network without having to reinforce all the time. And the reason why I'm giving you this update, you'll see that we're actually planning to roll out the A&M scheme in the beginning of by the beginning of 2023, but we're actually in the final stages of implementing our new network management system, and that's going to help us to facilitate A&M to be integrated. Now, we're one of the last DNOs to actually get an A&M system, but what we've actually used that time for is to learn from their experiences and to develop our own custom system, building on that learning. And the reason why it's also been a little bit delayed behind some of the other DNOs is actually the network that we've got is quite robust. So actually, it was better to kind of get it right and make sure that we've kind of we roll out a good system to start with, rather than necessarily doing things quite piecemeal. But in order to make sure that the system works to its maximum potential from day one, we need to start actually rolling out some of these flexible connections into business as usual. And we're in the kind of final stages of developing and building on our existing suite of flexible connections. So some of you will already be connected to some of these kinds of flexible connections, where we might have a remote terminal unit connected to your assets, and that allows us to send, at the moment, quite crude on-off signals to generation. In the future, what we're hoping for, or what we're developing, will be more kind of analog types of controls. So we'll actually be able to constrain rather than just switch off as standard. for abnormal running conditions, and that will help you to stay on for longer, and that will also mean that we can maximize the capabilities of the network and run it closer to its maximum potential. So benefits. It will help us to allow faster connections, requiring less reinforcement, potentially cheaper costs because we can utilize the existing capacity within the network, increase the amount of time that generators can remain on supply. So we're not just switching you off as standard for abnormal running conditions. Increased network utilization by utilizing the assets more efficiently. Decreasing the need for reinforcement, facilitating the utilization of flexible services, which allows opportunities for network users to provide services to us, facilitating a market for users to trade energy between each other, which is particularly useful for people like community and local energy partnerships, and increased network security of supply by increasing the speed of automated switching, which results in less network overloads and increases the speeds that we can restore following faults. So I'm going to go through a kind of typical example to explain how the A&M system works, just to kind of demystify some of it, and hopefully you can see some of the benefits. So this is a typical substation that we may have, and you can see from the loading on the transformer that actually it's only running kind of, you know, it doesn't actually run up to 100% a lot of the time. So actually we've got a lot of capacity in there that could be utilised, but at the moment is sitting unutilized. So that means that actually we have got some capacity in the network to fill those gaps and potentially run more in the kind of earlier parts of the day, and only when we get to kind of the tea time periods where we're already at 100% would we actually have to look at constraining. We also have the capability of running some of our transformers and some of our other assets a little bit harder under certain circumstances. So typically we can run them up to about 130% of their capabilities, but we can only do that for very short periods of time. And typically we tend to design the network to run at less than 100% to allow for the safety factor that we're not trying to run the network above the technology limits. So a typical double transformer substation. So we currently would run a set of two transformers at 50% loading on each transformer. And again, that's so that we don't ever breach the site's firm capacity ratings. And that's how we would typically design the network to run, so that we never run above 100% under planned scenarios. So neither transformers overloaded during normal operation. Now, if we bring in the A&M system, then actually we can increase that capacity on both transformers to 65% each of their single firm rating. And again, that means that actually the substation is in exceedance of what would be currently classed as the firm rating of the substation. And so normally without A&M we wouldn't be able to do that because we wouldn't actually be able to keep all the supplies active during abnormal running conditions. But what we've done in that scenario, so we've lost a transformer and all the load has transferred over to or load or generation, I should say, has transferred over to the remaining transformer that's left. So currently this transformer would be loaded up to 130%. And if we stayed with this over a sustained period of time, then actually we would start doing permanent damage to that transformer, and eventually it would probably trip out. But with the A&M system, recognises that we were running at over 130% of capacity. It then sends a command out to the demand or generation that it's controlling, or it will dispatch a flexible service, or it will reconfigure the network. It will use one of the three options, or it will use all three combined together, and it will generate what is the optimal solution to get that substation back within its firm rating. And it can typically do that within a matter of minutes. So in this example, we've shown that actually we can overload the assets from their current firm ratings. We've actually been able to operate the network with an additional 30% of capacity in this example. And if we were to follow the same logic across the entire network of 13,000 kilometers of cable, overhead lines, 44,000 kilometers of underground cables, and over 35,000 substations. Actually, that's a lot of extra capacity that we can get on the network. And combining things together so that we can balance generation and demand together actually may allow us to push the network even further than that. So if you're interested to know more about the active network management system, then we're happy to discuss it in further detail. I've tried to give you quite a quick overview of what the system is, and just to kind of demystify a little bit of it, because often it's not necessarily sold in the most positive light, but actually it should be a really good tool to help get people connected onto the network faster and to run the network more efficiently and allow more low carbon technology to be connected. The next part I'm going to go through is flexible services. So this links quite nicely. So embracing the zero carbon future and allowing more low carbon technologies to connect to the network. What we're trying to do is allow network users to participate and offer services to us for a financial reward. So in times where we've got network overloads through abnormalities or just kind of an additional load created by things like electric vehicles and heat pumps, actually we'll call on people to balance out that load or generation to actually facilitate those efficiency savings within the network. So how we do this is we offer out flexible services tenders. And for that, it's at the moment, it's typically for demand response. So we're looking at the moment for demand reductions, which can come from either reducing people's demands through things like smart charging of electric vehicles, smart home heating systems, but also generation. And generation is a really good example of this, where you can either have a single generator offering us a service, or you can have an aggregation of capabilities. And in return for providing us the service, you'll receive a payment. So to participate in these tenders, you must have an asset within one of our requirement areas. You must be capable of adjusting how much electricity you can consume or generate, and you must be able to provide a minimum of 50 kilowatts either individually or via an aggregator. And that's it at the moment in terms of requirements from us. We've got a section on our website which shows where the current requirements are. And we're due to be going out at the end of October with our next round of tenders. So keep an eye on that. And we've got different types of products that we ask for. So we've got some more kind of scheduled type services, right through to quite reactive services. So some of these will be, we'll be looking for them kind of years in advance, and you'll know your operating procedure years in advance. And some of them will be requesting closer to real time and dispatching in real time to meet the needs of the network. And if you want to get in touch, then you can email us. You can register your assets online through our Piccolo platform. You can have a surgery appointment with us, and you can sign up to our distribution list to hear about upcoming tenders and information. And the final bit I'm going to cover is the Accelerated Loss of Mains Change Programme. So this programme, for anyone who hasn't come across it by now, generators that were connected under G59 prior to February 2018, there's quite a large population of them that have either rock-off or vector shift settings that are non-compliant with the current requirements. And by September 2022, these will not be allowed to be connected to the network any longer. So to facilitate the upgrade of that, there's a program that's going through at the moment that's requesting that people replace their protection equipment or change the settings or just disable it, depending on what they've got on site. Things like inverters, it's either just change the settings or quite a large number of the inverters that are already compliant. But it's a really important program, and as of September 2022, there's likely to be an enforcement program. We're not fully sure of the details of that yet, but there is likely to be some form of enforcement to ensure that everyone connected to the network does have the correct settings as of 2022. And there's funding available for this, and there's quite a lot of sites still out there. We currently have 66% of our population that we either don't know if it's compliant, so it may need updating, or it may just need us notifying. But the key thing is there's a year to go on this program. There is funding available, and it's really important that this is done. And you'll find that throughout the course of this year that the funding will be decreasing. So it's important to get in early, make sure you get the most out of the funding. And if you're not aware of the programme, then just to make yourself aware of it, especially if you do know of any sites that were connected before February 2018. You obviously, a lot of you have the resources and the it's a potential extra source of business if you haven't already come across this for you. Thank you.
Okay, thank you, Keith. So that is the end of our presentations, but we do have a number of people from Leicester North West available to answer questions, including Keith. Do we have any questions or comments from anyone? Just raise your hand or type in the chat. Anyone? Okay, in which case, I think we are ready to wrap up. I have stuck a link in the chat for a short survey that, as I say, should only take a minute or so of your time. If you could give us some feedback, or alternatively, any comments in the chat or email the ICE mailbox. The presentation slides will be published on our website. What we will do as well is send them out to everyone who's joined us today. As I say, particularly in terms of the G99 application forms, if you do get a chance to have a look at those, if you have any comments, please let us know. As I say, we are looking at doing this and publishing the example forms on our website this year. So your input is appreciated. We do have a number of future events. They are available on the website, and there is a link here on the slides. And last but not least, thank you for your attendance. Lottie, if you would like to stop the recording, we will be, the panel will remain on if there are any questions from anyone who wants to ask.